Now continuing, let two infinite plane sheet of positive charge 1 and 2 placed parallel to each other as shown above. Now let sigma 1 and sigma 2 be the surface densities of charge on sheet 1 and 2, sigma 1 greater than sigma 2. Let vector E1 and vector E2 are the fields due to two sheets at due to two sheet 1 and 2 respectively. For points like P dash outside the sheets, E1 and E2 are in same direction. I have already explained this. So E equal to E1 plus E2, we use the two values, sigma 1 upon 2 epsilon naught plus sigma 2 upon 2 epsilon naught. 1 upon 2 epsilon naught common, we just take the sum of the two surface charge densities, and the direction is away from the sheet 1 and 2. And if you take point P between the sheets, then vector E1 and vector E2 are in opposite direction, with E1 greater than E2 because sigma 1 greater than sigma 2. So the net field at P will be E equal to E1 minus E2, equal to, using the two values, 1 by 2 epsilon naught common, we get sigma 1 minus sigma 2. Now there is a special case. If sigma 1 equal to sigma 2 equal to sigma, then the field at point P between the sheets, we just use sigma in place of these two. So E equal to 1 by 2 epsilon naught, sigma minus sigma will get 0 field. So if we have two infinite plane sheets having same surface charge density, then at every point in between the two sheets, the electric field is everywhere 0. Remember, it is not outside, it is inside. Now continuing, in a special case, if sheet 1 is positive and the sheet 2 is negative, with sigma 1 greater than sigma 2, then what happens? Just see the diagram. Here the first sheet is positive, having sigma 1 surface charge density, and second sheet is negative, having surface charge density sigma 2. Sigma 1 greater than sigma 2. Again we have to find field at P dash, which are outside, and P in between. Now here what happened, just have a look. For point P dash, the first sheet will produce field towards right. Don't forget the direction. How to get? You just imagine a test charge, positive test charge. But the second sheet will produce field towards left. So these two fields are in opposite direction. Similarly, for P dash on the extreme left, E1 is towards left while E2 is towards right. So here for point P dash, the fields are in opposite direction. So the net field would be the difference of the two fields. For point P, the field due to first sheet is towards right, repulsion, and due to second sheet is also towards right. It is attraction. Why? Unit test charge will be attracted towards the second sheet. So for point P, we just take the sum of the two fields. Now, for a point like P dash outside the sheet, E1 and E2 are in opposite direction. So the net field at P dash E equal to E1 minus E2. So E equal to 1 by 2 epsilon naught, sigma 1 minus sigma 2. If sigma 1 equal to sigma 2 equal to sigma, then the field outside the sheet E equal to 1 by 2 epsilon naught, sigma minus sigma equal to 0. Remember, if the two sheets, if we imagine two infinite sheets having positive and negative charge and same surface charge density, then the field outside everywhere is 0. It is very important part. Now continuing, for point like P in between the sheets, vector E1 and vector E2 are in same direction. So the net field at P will be E equal to E1 plus E2. It is the sum of the two fields. 1 by 2 epsilon naught common, sigma 1 plus sigma 2. If sigma 1 equal to sigma 2 equal to sigma, then we'll get E equal to 1 by 2 epsilon naught, sigma plus sigma, which is twice sigma upon 2 epsilon naught. On cancelling, we come up with E equal to sigma upon epsilon naught. This expression is very important. I'll be using this expression in one of the chapter capacitors. where the field between the two plates having equal and opposite charge, I'll take it as E equal to sigma upon epsilon naught. So there in the chapter capacitor, I'll use this expression directly.